Hey guys, I'm going to kind of go over these notes kind of quickly. So pause if you need to. Make sure you have all of this stuff written down so you can go back and look it over. We're looking at the geometric mean. The geometric mean, it says, is the average growth between two extremes, two numbers of two extremes. And this is still kind of like our proportions where you have, something over something equals something else, and we do that cross multiplication. The difference here is that we have x times x, which where the x squared comes from, and then whatever numbers you have for a and b, we'll multiply those. And to define the actual value, we go through and we take the square root. Here, the geometric mean, this is without the letters. So if we had the letters, we would have the value of 45 over x is equal to x over 5, or these could be used interchangeably. Either way, you're going to get x squared and then whatever 45 times 5 is, and then you take your square roots. So this is just showing that you can bypass that whole proportion and just, if you're finding the geometric mean between two numbers, go straight to the square root of their product. And so that's kind of what I did here in example 1 and 2. And then where we're going this, we're going to be focusing a lot more on these right triangles. And so the right triangle here, we're talking about the height, which is the altitude. Altitude always 90 degrees. So we're looking at the altitude of a right triangle. And so we're going from that 90-degree angle down to the hypotenuse. And that's going to be that is the geometric mean of the divided parts of the hypotenuse. That means this hypotenuse is being split into two parts because of that altitude. And so the way we can find these missing values is by taking the altitude over a part of the hypotenuse and setting it equal to the other part of the hypotenuse over the altitude. And so here, have it in words, and I have it same thing again, but with just the variables. So the altitude is represented by h over part x is equal to part y over altitude. And then we cross multiply. But I'm just showing you this is the general setup. And so that when you have examples later on, you can come back and see what are you looking for. So here's an example. We have multiple variables. We are just looking for that altitude. So what is this height from the 90-degree to the hypotenuse of the right triangle? So from the 90-degree angle to the hypotenuse, that's our z value. That's the altitude we're looking for. So I have my altitude over part, which is 8, is equal to my other part of 25 over z. Z times z is z squared. 8 times 25 is the 200. Square root. I did get a decimal, so I go ahead and round. Remember, you're in pre-AP. You need to be rounding to that third decimal spot. Okay, then we take a look here real quick at the next part. Like I said, pause or rewind if you need. This is talking about now you're looking for the legs. So not the hypotenuse, but the legs. So the parts of the right triangle that create that 90-degree angle. Those are called the legs, and that's also has a geometric mean of the hypotenuse and the adjacent part of the hypotenuse. So once again, we're looking at the whole hypotenuse and then part. And so since a triangle has two legs, there's two different setups you can use. So if I'm looking at just for the leg B, the left leg here, it's going to be the leg B over the whole hypotenuse. So the whole value is represented by C over part. So the part that's going to be adjacent to the leg, which means right next to, is X. So it's part of the hypotenuse X over the whole leg again. Or if we were looking for the right leg, which is represented by the variable A, it would be that leg, leg A, over the whole hypotenuse is equal to the part that's adjacent, so the part right next to leg, which is A, so, or excuse me, which is Y, over the leg A. Okay, so here's an example. Here we're looking for two values. So I'm looking for the leg first of the right triangle. So I have my leg over the whole hypotenuse, so 8 plus 25 is where my 33 came from, is equal to the part that's adjacent, the part right next to my leg value that I'm looking for, which is 8, over my leg, which is x. So x times x is the x squared. 8 times 33 is a 264. Square root, decimal, so you round third decimal spot. If we're looking for the y, so this would be the other leg. So it's going to be this leg, y, over the whole hypotenuse, which is 33, is equal to the leg that's adjacent, so 25, over the leg that we're looking for. Okay. Taking a look here at question 1, zoom in just a tiny bit. So here is asking to find the missing size, and this is how you're probably seeing it on your practice. It is practice, which means I am not going to take it up for a grade. I will see if I can input some answers in the Google Classroom to kind of give you a little bit more support. Make sure you're on the right track. I know this is a lot to take in, especially when I'm not here with you guys. So we're looking for the missing side. This side is a leg that I have, and I do know the altitude. So because I'm looking for one of the legs, I'm going to go ahead and choose to use this right triangle altitude theorem, where I take my altitude is equal to, excuse me, I'm so sorry, back up a little bit. I'm looking for y first. I'm looking for my y value first, okay? So because this is part of the hypotenuse, that's where I'm using the right triangle altitude theorem. So it says, so I'm gonna scoot over, it says altitude over part of the hypotenuse equals part of the hypotenuse over the altitude. So this is what I'm looking at. So my altitude is that square root of 3 over part of my hypotenuse, which is y, equals my other part, which is 1 over 3, the square root of 3, because that's my altitude. Square root of 3 times square root of 3 is just 3, and y times 1 is y. So y has a value of 3, that's why I have y equals 3 here. Now I can go ahead and go back and find my value of x. This is going to be one of the legs, so I'm going to go ahead and use the theorem from above, this one. I'm looking for my leg. I now know my whole length of the hypotenuse. I'm going to set it equal to the part over my leg. So my leg is unknown, it's my x, over my whole hypotenuse, which is not going to change, but it'll be a 4, is equal to my part that's adjacent, which is 1, over the part that I'm looking for, which is x. So we can see nothing's going to change, even though I switch numbers, because x times x is still x squared. 4 times 1 is still 4. Take the square root, and you get x has a value of 2. Okay. Sorry, I went over that one a little fast. All right. Then the last one here that I'm going to go over with you guys. The first part that I'm looking for, I want to find the whole hypotenuse. That way I can use my other theorem. So I'm looking for this x value. I do know the altitude is 2. So 2 over part of my hypotenuse 2 is equal to part of my hypotenuse, which is x, over the altitude. That's what the theorem says. Cross multiply 2x and then 4. Divide both sides by 2 and we get our x value is also 2. So a lot of 2's here. And so if x is 2, the altitude is 2, and this is a 90-degree angle, I know these two triangles are congruent by side, angle, side, which means y and z are congruent to each other. So I only need to solve really for one of them, and I just went ahead and chose to go with y. So this is a leg, so I'm going to use the right triangle leg theorem, which says leg over the whole hypotenuse, so that's going to be 2 plus 2, which gives us 4, is equal to the part that's adjacent, which is 2, the part of the hypotenuse adjacent to my leg, and then the leg. Cross multiply, which is where the y squared comes from, and 4 times 2 is 8. Take the square root, and you have your answer. Okay. Aside from these problems on your practice, you do have a few of Pythagorean theorem. Hope you remember Pythagorean theorem. It's a squared plus b squared equals c squared. Remember, round to your third decimal spot. I will be back in the class tomorrow. So if you have questions, save them for me then. All right, good luck.